ceramic magnets have been around a long time. They're one of the earliest forms of magnets after they discovered magnetism and started using magnetism from the original lodestone. Then they went to the iron core magnets, and then we had ceramic magnets. And ceramic magnets are very interesting. They're reasonably strong. They're certainly nowhere near as strong as a neodymium. Depending on size and the design of the magnet, it can be, you know, a neo can be 10 times or more, maybe even 20 times as strong as a ceramic magnet of the same size. However, there are several good applications still where a ceramic magnet is a better magnet just because of cost. The ceramic magnets are much less expensive, and when you don't really need the intensity of a neodymium magnet, then the ceramic magnets make an excellent choice. Some of the good applications for it is like these large brick magnets have been used in a variety of applications. One of the more interesting applications is that they use it for separating material on conveyor belts. If you take an array of these and line them up so that the conveyor belt's moving underneath it, they have the ability to pull the metal out of the conveyor belt. So we've had people that are processing everything from cloth to produce to, you know, different things where they think little scraps of metal might get into it, and they want to make sure they pull it out before it goes into other equipment. These do a great job. You might want 6, 8, or 10 of these lined up, get it 3 or 4 inches above the surface, and it should do pretty well at pulling stuff out. Obviously the Neo is better, and there's some other applications where you might use that as your final step, where the Neo, different assemblies of Neo have the ability to pull it out, pull out even the smaller particles that these may miss. Some of the other things that we use it for is in, as you see from the ring magnets, these are used as speaker magnets. Virtually all of your mainstream speakers, not your higher end speakers, the really high end speakers are all Neo at this point, but most of your speakers are going to use these ceramic magnets. The ceramic magnets require a molding process, and this molding process is very expensive. It can run $2,500, $3,000, $3,500. But if you're wanting the lowest cost on something you're going to mass produce and you just need the magnetic power and you don't need the intensity of a Neo, your best bet is to go with a ceramic magnet, and then you're paying for the cost. But you would be needing to get into the 100,000 pieces or more. If you're paying $3,000 for something to get a mold made, and you're making 100,000 pieces, then your cost of the mold is only 3 cents per piece. Whereas then you're paying for the magnet part. If you get into 1 million pieces, it's 3/10 of a piece. So it really makes a difference. We have a variety that have everything from long, skinny magnets that are like this, that we're able to use, and a lot of people have good applications for these based on their holding power of the ceramics. We have a giant ring magnet. This is the largest ring magnet I've been able to find. It's a little over 10 inches outside diameter, and it's 1 inch thick. This puts out an enormous magnetic field that spreads way out and has an influence on the objects around it, and it's very heavy. But if you're looking for an extremely powerful ceramic magnetic or a large area magnetic field, that's going to be the best one for you. We have a lot of these that people use in hobbies and crafts and everything, little 3/4 of an inch by 1/2 inch by about 1/8 of an inch thick, and our little rectangle 750Cs on the website. These work very well for just normal little holding applications and holding things up. Again, they're definitely not going to be as strong as Neos, but they might be a little bit easier to work with. A couple of the other factors to keep in mind with ceramics is ceramics are very susceptible to losing their magnetic force over time. These are the magnets that after 2, 3, 4 years you begin to see the strength drop off. They're also susceptible to impact. The more they impact each other and bounce together, the weaker the magnetic field is going to be. So this is some things to keep in mind. The magnetic field on a large area magnet like this does not drop off as fast as a Neo. This may measure 17, 1800, 1900 Gauss at the surface, and then over distance it drops off, but it doesn't drop as fast as the neodymium is. A neodymium this size might measure 5400 Gauss, but then when you get this far away, you're down to 1000 Gauss. This may start at 1900 Gauss and you get up to here and it may be 400 Gauss, 300 Gauss. So it's dropping, but it's not dropping quite as fast as a similar size Neo is, because the field intensity of a neodymium magnet, the larger it is, the more it's going to hold that field close to the surface of the magnet. That sums up the ceramic magnets. If you have any other questions, don't hesitate to ask.